So we've dealt with that quantitative data in a single variable, and that single variable, okay, we talked about this word, bivariate. I lied, not bi, it is univariate. Okay. One variable. We talked about baby chicks or the number of video-enabled devices. So now, like I said, we're going to step away from that quantitative data for a minute, and we're going to talk about some categorical data, or data that shows how many things surveyed fall into a given category. Okay, so categories: eye color, hair color, and stuff like that. So if we did a quick survey in this class, okay, raise your hand if you have brown eyes. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, raise your hand if you have blue eyes. 1, 2, 3, 4, 8, 9. Okay, green eyes. 1. Okay, other. Like hazel eyes. 1, 2, 3. Okay. All right. So it says all those surveys of data that contain only one category are interesting. Okay, it's kind of interesting to see that, the eye color in this class. But we like to see how two categories can be related to each other. So now let's take that eye color and then let's throw in hair color and see if there's any relationship between a person's eye color and hair color. Another example, it says, we may want to know how a person's gender, say male or female, one category, affects what profession, a second category, they would prefer when they grow up. Seeing if there's any association between those two categories. So we're going to organize our information in a two-way frequency table. And I have here a class of 20 students recorded their hair color, okay, one category, and eye color, which is shown in the table. So we've got hair color along the top, black, blonde, red, and an eye color, blue, brown, green along the side. And we have, this is called, like I said, a two-way frequency table. These here, okay, are your margins, okay, nothing earth-shattering there. And then this in the middle, we're going to see on the next page, are going to be called the joint frequency. Okay, the joint frequency. So this is the marginal frequencies that I highlighted in yellow, and then the joint frequencies come into the center. So how many students had blonde hair and blue eyes? Anybody? 4. Okay. Blonde hair, blue eyes. How many students had red hair? 4. Okay. We're talking about that total there. Okay. Now it says construct a table that shows the joint relative frequencies and the marginal relative frequency. So what that means is now we're going to take this table and we're going to put percents to them. Okay? So your percents are your part over your total. So if I want to know what percent of people had black hair and blue eyes, is how many people? 3 out of how many people total? 20. So 3 out of 20, yep, is 15%. So then the second one, what's the percent going to be for blonde hair and blue eyes? 20%. Okay. What about the next one? 5%. Okay. And what about this total out here, the marginal frequency? 40%. All right, go ahead, fill those in. Okay, guys, what's the key? What are we just multiplying by if the total is out of 20? We're just multiplying everything by 5 to get those percent. All right. Those are percents. I didn't put my percent signs everywhere. Okay? All right, go ahead, flip it once you have those percents filled in. We'd like to understand, okay, associations or trends within the data. So that first page was, again, the number crunching. Now let's interpret that information. See if there's any sort of relationship between eye color and hair color. Would a response to one category tell us something about a response to the other category? So we're going to use that same table, and let's see if there is a connection between eye color and hair color by using conditional relative frequency. So now that's a little bit different. Conditional relative frequency. It's not just the relative frequency. Okay? It is, we're basing it on a condition. So I've got that same table there. And the first question says, what is the conditional relative frequency of having green eyes if you have red hair? Now, before you answer that, look what's inside the parentheses. It says this is equivalent to asking what the percent of people with red hair have green eyes. People with red hair have green eyes. What is that? Bill? 25%. Yeah, it's what over what? It's 3 over 4. 75%. Think about it this way. Of all the people with red hair, how many of them have green eyes? All the people, let's see, with red hair, how many of them have green eyes? What is the conditional relative frequency? Now, like I said, the conditional, the total is thinking about the specific condition. It's not out of the grand total like we were on the front. What is the conditional relative frequency of having green eyes if you have black hair? What is that? 1/9. Okay. 1/9 or 11%. Okay. There are 9 people with black hair, and of those people, 1 of them has green eyes. So we did a little calculation there, so now let's do some interpretation. Does it appear that having green eyes has a dependency, or at least an association, with having red hair? Does it appear that having green eyes has a dependency, or at least an association, with having red hair? So overall, let's think of the total here. Look at the total. How many people out of 20 have green eyes? 5 out of 20 have green eyes, right? Which is 25%, right? If you look at your answer, okay, to part A that we came up with here, okay, what does that percent jump to now if you have red hair? We said in part A, okay, all of a sudden that percent is 75% if you have red hair. So would you say that green eyes has a dependency or at least some type of association with red hair? Yes. Absolutely. Okay, part D. It says, is it more likely, okay, so now we got a comparison here, that a person, let's see, let's highlight, that a person with black hair has blue eyes, or, this is the other piece we're going to look at, a person with blonde hair has brown eyes? Use the conditional marginal frequencies to support your answer. So let's do the one I highlighted in green. Of all the people with black hair, how many have blue eyes? All the people with black hair, how many have blue eyes, Nick?
3.
3 out of 9, right? Which is 33%, right? Now let's look at this. Or that a person, all the people with blonde hair, how many of them have brown eyes? 2 out of 7, which is 29%. So which one is more likely to happen? Right? Black hair with blue eyes. Oh, let's go back to that. This was interesting. Back in Part A, it says people with red hair have green eyes. Madeline, I think you're the only redhead in here, right? But you don't have green eyes, do you? I had 3 redheads in my other class. It was Maggie Anderson, it was Jack Leach, and Liam Bell, like strawberry one. None of them had green eyes. I was like, that. So, all right. So I don't know how reliable our data is here. Right? All right. So it says a survey of 52 graduating seniors was conducted to determine if there was a connection between the gender of a student, male, female, or whether or not they go to college. Based on this data, what is more likely? What is more likely? That someone going to college is female. Of all the people going to college, of those, how many are female? That's one thing. And then the other piece is that someone who is female is going to college. So, what do we have for the first case? Someone going to college is female. What is that one, Sam? 13 out of 29. All the someones going to college, of those, how many are female? 13 out of 29, which is 45%. So now let's sort of do the flip of that, okay? Someone who is female is going to college. So all the someones who are female, meaning how many females are there? 22. Of those 22, how many are going to college? 13, which comes out to be 59%. What's more likely? Okay, someone who is female going to college. Okay. Okay. Simple enough.